Ladies and gentlemen, please welcome Senior Vice President and General Manager, Networking and Security VMware, Tom Gillis.
Good afternoon. I'm Tom Gillis, General Manager for Networking and Security here at VMware. And we're going to talk about networking and security for the cloud era. So, in my travels, I meet many customers, and I always ask them a simple question. What problem are we trying to solve? And what I hear back pretty consistently is, we're looking for agility. We're looking for flexibility. We're looking for time to market. We're looking for speed. We're looking for the public cloud experience in our private cloud infrastructure. And what does that mean? It means that I want to give my developers the ability to launch a workload with a single click, which is a good idea, right? And I ask, well, how are we doing on that journey? And the answer is, oftentimes not quite there. So maybe we have to have automation that can deliver a single click and a single ticket, because someone has to manually update a firewall rule or manually provision the VIPs in a load balancer. And this is the state of what many of our customers are, where we haven't quite been able to deliver that agility. And I'll argue that partial automation is an oxymoron. It's like a partially built bridge, right? It's useful if you're fishing, you stand at the end and throw a line, but if you're trying to get from one side to the other, it won't do the job. And so at VMware, our vision is with a software-defined data center to deliver that public cloud experience in your private cloud infrastructure. And the job of NSX is to provide all of the networking functions, all of them. So that means switching, routing, and you know us for a distributed firewall. What we're pleased to be announcing at the show today is that we're completing the security capability with distributed IDS/IPS. And we're going to talk about that in a little more detail. With the introduction of Avi, we have a fully featured load balancer, global load balancer, and WAF capability. So we have all of the core network services that you need to deliver that public cloud experience in your private cloud infrastructure. And as workloads more and more are moving into cloud native format, NSX Service Mesh has the ability to extend up into layer 7 and provide those same consistent policy enforcement security capabilities for VMs and containers alike. But we don't stop there. It's not just in the data center. With our SD-WAN capability, we can deliver network virtualization that can deliver application performance end-to-end, all the way to the end user. And we wrap it with things like VRNI, our advanced analytics, to provide monitoring and to simplify and streamline operations. And I think that's going to be one of the recurring themes you're going to hear from us today, is about simplifying, delivering better security, easier to operate, easier to operationalize. So I want to touch a little bit on the newest member of the NSX family, which is Avi Networks. I sometimes like to say that Avi is the NSX of load balancers. And the reason I say that is that it's architecturally very, very aligned to NSX. The core concept here is that you have a central control plane that allows you to set up and administer policy separate from the data path. So the data path is like a little robot that can do the actual job of load balancing, but it's all managed by a central brain that can scale up and down dynamically. And this allows us to deliver consistent policy enforcement, security capabilities on the front end of your web servers, whether those web servers are running in a private cloud or public cloud infrastructure. It's all software defined, it runs on general purpose hardware, and it's all API driven, so it's very, very consistent with that one-click public cloud experience that I was talking about. I think one of the most unique aspects of our software load balancer is that it provides tremendous elasticity. And I'll talk about this with a little example. And lastly, we've built in pervasive analytics that allow us to measure application response time and ensure a consistently good end user experience. So here's how it works. You've got a certain amount of capacity in your data center, let's say in Paris. You set up the Avi controller, and then the control plane, the data plane, is what we call a service engine. That's the little robot that's actually doing the job of load balancing. It's controlled by and talking to the controller. So it allows you to auto-scale an application. As your traffic on a website grows, we'll launch more VMs behind that load balancer. We integrate with VMware's orchestration systems to auto-scale up and down. But at some point, the load balancer itself is going to run out of capacity. So here's a question. When your load balancer is running out of capacity, what do you do? If you're using a hardware load balancer, you call your sales rep, you order more hardware. In the case of the Avi system, we can just simply scale the load balancer itself and then continue to scale the applications behind, right? Easy. No special hardware, no fancy salesperson involved, no sushi dinner. It just works, right? You can get this stuff to work. We have the ability to do not just private cloud, but we can do the same capability in the public cloud. So using the global load balancing capability, when you start to run a capacity limit in your own data center, we can burst into the public cloud. And so during a holiday or peak time, you can have a split capacity across multiple different pieces of infrastructure, and it all just works. It scales up, it scales down, it's automatic, it's efficient, and it's all defined in software. It's because of functionality like this that we've had tremendous amount of success and adoption in the marketplace. So for those that attended at this stage last year, we were pleased to announce that we had over 7,500 customers. We're pleased to announce today that we have more than 13,000 customers. So we've almost doubled our customer count in just a year. When you get that kind of market adoption, something has to be going right. And it's not just lots of customers, but we've got the largest customers in the world. So 89% of the Fortune 100 have chosen VMware to virtualize their network infrastructure. A big area for us in recent times has been adoption by telcos. So as the telcos begin to build out their 5G networks, 5G has lots of little points of presence. There's lots of towers involved. And so it becomes unwieldy for them to think about a hardware-based points of presence and a hardware-based network infrastructure. They have to virtualize. And if they're going to virtualize their network, who do they look to? The leaders in network virtualization, VMware. So 8 of the 10 largest telcos have chosen us. And I think one of the more interesting parts of our portfolio is our SD-WAN capability. I think by many metrics, or the industry analysts, if you look at market share, we're the #1 vendor in this space. And the reason we're #1 is that this is one of the few pieces of networking technology that has a dramatic impact on the end user. It's really astounding to me. When I go talk to customers, and I talk to them all around the world, the response I see from users that have deployed one of these things, I haven't seen an end user impact since the early days of WAN acceleration with Riverbed. I don't know if you remember that, but the ability to plug this box in the network and all of a sudden the network just works. And we're specifically focused on streaming applications, so things like Zoom or WebEx. Like if you've ever advanced a slide and all of a sudden the audio stops, that's something that people feel a lot, and we solve that problem with our SD-WAN capability. Lastly, if you have done any e-commerce, if you've ever watched a television show or a movie on a streaming service, if you've purchased concert tickets or movie tickets online, you've probably already experienced Avi, because Avi is the software load balancer that is handling 4 of the largest consumer websites on the internet. And the reason we're having this success in the market is because there's a very clear return on investment that comes along with network virtualization. So the first and most obvious to measure is capital expenditures. So we have a tool that will analyze your existing infrastructure. We'll run through all your servers and all the things that are running in the data center and look at its utilization and identify stranded pools of capacity. It's a really great tool, and we've run this now across thousands of enterprise customers. And what we have found is on average, 59% improvement in CapEx utilization. So think about that for a minute. In an era where we're trying to squeeze 5% out of our existing IT budgets, if you can get a 59% increase in the utilization of your existing hardware, we have many customers that can put off hardware refresh for 2 or 3 years by just making better use of their existing infrastructure through network virtualization. And all of this software automation, all this one click that we're talking about, what that means is it saves time. Time is money, and so we see on average a 55% increase in OpEx savings. So there's an enormous ROI. Oftentimes an investment in network virtualization can pay for itself in just 1 year. Now what we're going to talk about in the remainder of the show is focus on some of the advanced security capabilities that we're introducing with NSX. So to go in a little more detail, I'd like to invite Ambika Kapoor to come up and join. Ambika is our Vice President of Product Marketing and a security industry veteran herself. Ambika?
Thank you, Tom. When it comes to security, our philosophy at VMware is intrinsic security. Intrinsic security is security that is built in, not bolted on. So what do we mean by this? Think of an apartment building. If you add the security after the fact, it can actually look pretty awkward. Bolted on security simply does not work that well. Now contrast this when you think about security up front. When you design it in, you build in the surveillance system, you build in the fire escape, and you build it differently. This is a really important point. With intrinsic security, we are not trying to take existing security and integrate that in. we are trying to reimagine how security actually works. And here, we like to draw a contrast between integrated security and intrinsic security. So an example of integrated security is when you take a hardware firewall and you make that a blade and you put that into a data center switch. It makes it more convenient for customers to deploy, but it doesn't actually improve security. And that's not what we've done with NSX. We didn't take existing firewalling capabilities and integrate them into NSX. Instead, we use the intrinsic capabilities of our platform to reimagine what a firewall could be. So to see what we did, imagine a data center infrastructure in which we took the hardware firewall and we broke it into thousands of pieces of software and applied them directly to the servers in the hypervisor. Right? With this architecture, now you can have the firewall be wherever your workload is. There are no blind spots in the data center, and this is better security. Now, this capability has been out for a while. A lot of you are probably familiar with it. Like Tom said earlier, what we are announcing at the show is we are now bringing this philosophy to the IDS and IPS. So just like with the firewall, our IDS IPS takes the signatures that it's got, pushes them into the hypervisor, and then directly applies them to the host, to each host. Now, this has the benefit that you remove those bump-on-the-wire boxes that can be really expensive, hard to deploy, hard to manage. But it has a less obvious benefit that I want to emphasize. It lets us be really fine-grained and intelligent about how we apply the rules. Now, if you're familiar with the traditional IDS IPS, you know that there are a couple of challenges with it. An IDS IPS typically runs all of the rules on all of the traffic. So you need hardware-accelerated regex to actually do that. But there's another problem. Because you're running all the rules on all the traffic, you end up having a lot of false positives. The IDS IPS is noisy, and that makes it less useful. So when we built this out, we decided to take a completely different approach. Now, to get this and describe this approach, I want to step back and explain that IDS IPS signatures are written on an application-specific basis. So if you're running Apache, you'll look for a certain set of things. If you're running MySQL, you look for a completely different set of things. And NSX has an intrinsic understanding of the application. So NSX can actually tell the difference between Apache and MySQL. So what we do is we use that context to curate the rules. Instead of applying this monolithic set of rules to every piece of the traffic, we take only the rules that are applicable to a workload and push that down to the workload. So I guess you can immediately see the benefits of this, right? The first thing is you reduce the rule set. And what does that mean? You no longer need hardware regex. That's a big deal. The other thing is you're not applying Apache signatures now to Nginx traffic or Tomcat signatures to, let's say, some other traffic. And this means you get lower false positives. So it's things like this that make our IDS IPS a better solution. Now, this approach that we have of attaching the IDS IPS signatures to the workload, and along with that, attaching the firewall rules as well as the network rules to the workload, has a lot of operational implications that are very good. So when you're scaling an application and you bring up a workload, we automatically apply the right rules to it. If you decommission that workload, we expire the rules automatically. If you vMotion a workload from one machine to another machine, the rules go with it. And what's really cool is we maintain state, so no connections are dropped. And we also apply the networking rules, the firewall rules, and the IDS IPS rules in a single pass. And this has some really good implications for performance. Now, all of these operational things that I've talked about have a lot of value, even with this really simple 3-tier app that I've got up here. But that's not what a lot of the apps you're dealing with look like, right? A lot of your apps look a lot more than this, especially if it's a cloud-native app. It could have tens, hundreds, even thousands of services, and a lot of them might be ephemeral and short-lived. So in this world, it is really, really hard to manage security if you don't have automation for creating the rules, for deploying the rules, and for managing the rules. And that is something that we deliver to you. Now, I want to end on one important point. As you continue to attend the different sessions at VMworld, you're going to hear a lot from us on containers and the VMware Tanzu portfolio. For us, for NSX, VMs and containers are both first-class citizens. So NSX is the networking and security backbone that deals with all of those. So just remember that as you continue to hear that. And thank you, Tom.
Awesome. Thanks, Ambika. So you heard Ambika talk about it. Yes, thank you. You heard Ambika talk about it. You heard Pat talk about it this morning. You heard me talk about it. We talk about intrinsic security. And what we mean is not integrated security, but taking advantage of the intrinsic capabilities of our platform to do security differently. And let's talk about how this works at the data center scale. So there was a high-profile attack on a credit rating agency that had a single unpatched server. Can I just quick show of hands? Anyone that thinks they might have an unpatched server somewhere in their infrastructure? Okay, every hand should go up, but okay, fine. That's fine. We'll be honest here. So a single Apache server allowed an attacker to land code on the box. But from that point, they were able to traverse 48 different servers. And stay in the network for 9 months. Think about this in the real world. If someone breaks into your house and steals your laptop, you'd be mad, right? How about if someone breaks into your house, stays there for 9 months, goes room to room, listens to every conversation, reads all your email, goes through your credit card statements, right? It's unthinkable, and yet that's what happens in the cyber world. And so our vision of VMware is we make the assumption that no matter how hard and strong your perimeter is, somehow, some way, someone's going to find a way in. And our job is to make sure they don't stay in, or make it really hard for them to traverse throughout the network. So how do we do this? It starts with ensuring a strong foundation. Built into vSphere, we've built vulnerability scanning. So let's try to eliminate the obvious mistake. If you're launching a new server and it's not patched, let's at least identify that and stop that. The second thing is, let's apply world-class endpoint protection. You know, with the introduction of Carbon Black into the family, we're going to seamlessly integrate this. I talk to many customers that will tell me that they've got as many as 10, 15. I've talked to some customers that have 20 different agents that they run on their data center servers. 20 agents. So the opportunity for misconfiguration and mistake is really, really high. As we make an agentless insertion of world-class AV, we're giving you a strong starting point to make sure that your infrastructure is as hardened as possible, and we're reducing the attack surface. The next step is we want to carve that infrastructure up into logical pieces that make sense. Microsegmentation is about allowing flows within an application that are known and disallowing everything else. It's a really simple concept, but it can be hard to implement at scale. And so this summer, we introduced a new technology we call NSX Intelligence, and I'm going to actually, Jacob is going to come up and join me in a little bit. We're going to show you a live demo of NSX Intelligence and its ability to understand an application topology and to automatically generate the firewall rules. This is really, really important if you're trying to do microsegmentation at scale, because that's our goal, is to make this stuff easy and consumable. You know, recurring theme there. Easy, consumable, but world-class security. So what does microsegmentation do? It stops what I call the foundational problem, which is a web server should not be allowed to connect directly to a database through some random port and protocol. Right? Seems to make sense, but it's actually hard to do at scale. We're going to make that easy. So I'm going to give everyone an opportunity to pretend that you're a network security analyst. Let's analyze this traffic and see if we can identify the anomalous driver. Anywhere? Right? I know you're all in Spain, so you're like, no, that looks perfectly normal, but like, no, it's not what we want to see happening. So the web server connecting to a database, that's the anomalous traffic. It doesn't take machine learning to identify and stop that, but we want to build that foundation to guarantee we don't do that type of flow in your infrastructure. Now we're moving to the next step let's understand the content itself and be able to filter traffic that would otherwise appear legitimate, and that is stolen credentials or compromised machines. To a network-only solution that's doing port blocking, that traffic is going to appear normal and it's going to go flying through. But that is the traffic that's causing most of the problems. So let's talk about how we can solve that problem. With our distributed layer 7 aware firewall, and now with the IDS IPS, we can scan traffic that would otherwise appear legitimate and identify friend from foe. So when ransomware is trying to propagate like WannaCry as it's moving through your infrastructure, it's taking advantage of the SMB port, which is a protocol that has some certain vulnerabilities built in. Oops. So it takes advantage of our layer 7 capability where we can read that SMB traffic and say, this is legitimate traffic? No, this is WannaCry and it's propagating in your network. So we have the ability to identify friend from foe and to stop malicious traffic that would otherwise appear and pass through, appear normal to a regular port blocking solution. So moving beyond microsegmentation to doing true internal firewalling capability. Now with the introduction of Carbon Black into the family, we have a unique opportunity to leverage Carbon Black's contextual understanding of the workload with NSX's understanding of the network and flows. And so think about an example where Carbon Black understands deep details about what's happening within the server. So let's imagine it's an Apache server. We know all the different processes that make up that Apache server. And let's imagine we see a new process in one of your Apache servers, and this process is called abc123xyz.exe. First of all, it's just kind of a weird name for a process. Secondly, we don't see that process running in any of your other Apache servers anywhere in your fleet. And thirdly, we don't see that anywhere in our global understanding of Apache. So we're like, okay, that's really weird. The next thing we'll notice is that that process makes a DNS query to a server in Eastern Russia. Okay, that's also weird. Right after that query, it's going to make 258,000 a request to the database for 258,000 credit card numbers. We've seen enough. We don't need signatures to know that's an illegitimate flow. So having this broad contextual understanding of both the workload and the network is what Gartner is calling XDR. It's the combination of EDR, endpoint detection and remediation, and NDR, which is network detection and remediation. We bring them together, and we do it in a way that makes it simple and easy to operationalize. Again, recurring theme, taking world-class security, building it into the infrastructure, leveraging our unique capabilities to do things in a way that is easy for you to operationalize. And all of this is designed to be implemented as code. Coming back to that one-click thing I was talking about, right? So if your infrastructure and your security policies are built as code and part of your CI/CD pipeline, there's much less chance for human mistake. This stuff is easy to use. And the reason we're able to implement all this as code is that there's been significant advances in the capability of general purpose CPUs. So VMware has been working very closely with Intel on a hardware acceleration capability called DPDK, which is data path acceleration. And what it does is it allows a general purpose CPU to process network packets at faster than line rate. So what this means is that we can see all that network traffic and we still have CPU power left over to do network processing. And prior to this, you had to use dedicated hardware to perform a function like load balancing, like firewall, like IPS, or network analytics. And it was always interesting to me when I would go talk to customers and to look at the physical data center. And you see racks and racks of servers, commodity servers that are doing the job of running your applications. But oftentimes you'll see racks of this other stuff. And I'd say maybe as much as a third of the data center can be tied up with this other stuff. And what's this other stuff? It's load balancers, it's firewalls, it's the IDS IPS, it's network analytics. And the architecture was, let's hairpin traffic out to these dedicated black boxes, which are expensive proprietary systems. We're hairpin traffic over there to perform the service and move it back. So now, with this advancements in general purpose processing, we can replace these proprietary systems. We can define them in software, and we can distribute them and run them across a grid of general purpose compute that's being used to power your actual applications. So load balancing, firewall, IDS, IPS. One of the big areas of interest these days is network analytics. The challenge you have with network analytics is it involves tapping. Anybody here doing tapping? Again, show of hands, lots of hands go up. Network tapping means you're going to make a copy of everything. So you move all of the packets to the data. So this last rack of hardware on the right, this is an example of the hardware required to run a network analytics program like tetration. It takes a minimum of half rack, and it's usually a full rack because you've got to build a big giant data lake to take all those tap packets and assemble them to do analytics. And our approach is, instead of moving the packets to the analytics, what if we went the other way? What if we moved the analytics to the packets? And so use a distributed architecture to push all of these functions, load balancing, firewall, security, and advanced analytics into the hypervisor, and we can use thousands of CPUs, not hundreds, but thousands of CPUs in a distributed fashion, so we have a much more powerful fabric, much more powerful infrastructure, but literally you can free up space and power in your data center by getting rid of these proprietary systems. So it's a really powerful concept, and this is how the public clouds operate. they're not buying these dedicated hardware devices. They implement infrastructure and software and can scale it up and down. We're giving you the public cloud architecture and the public cloud experience in your private cloud infrastructure. One of the big announcements that we have for NSX is with 3.0, we're going to be introducing policy federation. So those NSX controllers that I talked about, they can federate. What this means is you can have a single console where you set up those security policies, you set up those network policies, and then you can push those policies to multiple different data centers. In the first release, we're focusing on multiple different private cloud data centers, but in the second release, we'll be able to push them into public clouds as well. So if you're a hybrid deployment, we've got stuff on-prem and in a private cloud, we can push the policies globally. Not only do we have centralized policy administration, but we also maintain state, which means if you vMotion a workload from one data center to another, we'll move all the layer 2 networking functions along with that workload, and we'll also move the firewall IDS IPS. Again, what are we driving for? Operational simplicity. We make this stuff work, and we make it work well, and we make it work at scale. So this federation capability is something we've been working on for a long time because it's a very elegant architecture that allows us to scale significantly to meet even the needs of the largest enterprise customers. Now, what's really interesting is the same concept of using a distributed architecture to get rid of proprietary systems. That works in the data center. It's also taking place on a global scale with SD-WAN. So in the world prior to this, we used to have an architecture that involved a hub and spoke network for your WAN. So if I was at a branch office in, say, Lima, and I wanted to access Office 365 servers that might be in Sao Paulo, the MPLS circuits would backhaul that traffic from Lima to a hardware DMZ that might be in New Jersey, and then filter the traffic and then allow it to go to its destination. And so that creates a very inefficient architecture. And so we thought, what if we could change that? What if we could take that DMZ and break it up into little pieces and distribute it, just like we did in the data center? And this is the concept behind VMware SD-WAN. So we take the DMZ and we put it into points of presence we call cloud gateways. And there are thousands of cloud gateways that are running in hundreds of physical points of presence around the internet. And the idea is that we can intercept that local traffic, apply the security policy you need, and allow it to go to its destination without hairpinning it around the globe and creating enormous inefficiencies. So this is one of the reasons customers love our SD-WAN capability, because you're streamlining and simplifying the network architecture, making it easier for stuff to get from point A to point B, but to be able to inject world-class security like firewall, IDS, IPS, web proxy, advanced anti-malware. All these capabilities are integrated in a way that you can deliver a better end-user experience and at the same time improve the enterprise security of your infrastructure. And so it's capabilities like this that are allowing innovative companies to fundamentally change the way they operate. One of those companies that I've met along the way is Pirelli. I'm particularly keen on Pirelli because I have a personal connection. I'm a bicycle racer. And when you're coming down a mountain road at 40 miles an hour on your bike, you really care about the tires on that bicycle, I tell you. And I only ride on Pirelli tires. So let's roll a video to show a little bit about what Pirelli does as a company. Can we see the video, please? So I'm pleased to have Giuseppe Fiorentini from Pirelli. Giuseppe, please come up and join us. Hi, Giuseppe. So Giuseppe, tell us how partnering with VMware has helped Pirelli achieve your business objectives.
VMware is a historical partner for Pirelli. We started about 10 years ago with the first virtualization project based on transformation from physical to virtual, all server in the data center. After that, we extend the solution, the VMware solution, to the remote branch, and at the end, on the plant in the data center. With VMware, we are working on a Pirelli digital transformation program, and VMware is supplying a new operating model for the data center flexibility in the plant based on SDDC. We also supplying use case design, the new use case for network virtualization, microsegmentation, routing virtualization, and security insertion, and also deploying the new SD-WAN technology for the network transformation program.
Yeah. So like we talked about SD-WAN, can you describe how SD-WAN is helping Pirelli change and achieve its business objectives?
Okay. With SD-WAN deploy, we increase flexibility. Now we are telco agnostic. On the remote branch, we can use different technology, MPLS, broadband, and mobile. We have also increased agility. We have reduced the time to deliver the new site and increased efficiency with zero-touch provisioning and network automation. We also reduce the spending on the WAN transport and increase the user experience on the cloud application with local breakout session.
So how are you using NSX and SD-WAN in your environment?
Okay, about NSX, we have finished the pilot with the NSXT, with the last release with the service insertion for the security feature, and now we are ready to transform current network data center in the plant based on hardware and legacy solution to the new full virtual stack based on software. About the cloud, we have finished the test with VMware on the cloud, and we are very interested to the ACX solution in order to create the virtual network fabric between the on-prem and the cloud.
Yes, yeah, great. And you're in the midst of that SD-WAN rollout. Tell us how that's going on a global basis.
The SD-WAN rollout is going very well. We have migrated all sites in Asia Pacific and in EMEA, and at the beginning of next year we will start with Latin America and North America. Currently we have achieved some result. One of the results is to improve the network bandwidth of the remote site. We improve network agility with a one-click configuration, yes. Zero-touch provisioning. Yes. We have increased security because all links are encrypted. And last but not least, the controllers want to use more internet than MPLS. So probably the next future, the next one for Pirelli will be based on internet connection.
Internet as opposed to dedicated circuits. Great. Giuseppe, thank you so much for joining us.
Thanks.
Blanketing the world with SD-WAN. So this is really what the heart of network virtualization is about. We've talked about the virtual cloud network, tying together everything from branch to core to cloud, smoothing out and making it easy to deal with an increasingly distributed, heterogeneous infrastructure, tying it all together with advanced analytics. So now it's time to actually show you some hands-on practical advice on how you can bring this stuff to life in your environment. So Jacob Rapp is going to come up and show us some demos of how we can deploy world-class security with that one-click experience. Jacob?
Hey, Tom. Thanks for having me.
Thank you.
Great. So, Tom, you mentioned early on that we're trying to get to this one-click experience. And to do that, we need automation.
Yes.
So what we hear from our customers is that automation can be really hard to do. You need a bunch of API calls, and each of those API calls returns this UUID. That you kind of need a lot of really smart people with a bunch of stickers on their laptops to really start understanding this.
Yeah, just because it's software doesn't mean it's easy.
Yeah, exactly. So this, as you pass this UUID from one API call to another API call to another API call, if you get any of them wrong along the path, then the whole thing falls apart.
Right.
So with NSX, we created this declarative API model, where we need one API call and one file. So with that, let's take a look at the demo. So first off, we need an app. We want our app tier to talk to our database tier. So we need a gateway. Really simple human readable file. Let's click add it to our JSON file, and we have our gateway. Next up, we want our gateway to communicate with our applications. So we need our segments. So we have a segment for our database and a segment for application tiers. Next up, no automation would be complete without security, right?
Right.
So now we're adding in our security roles. So here we have a source group of app, destination group of a database, and then that MySQL traffic. Again, this is our layer 7 app ID functionality, so we're able to see all the way to what the actual protocols are.
So this is infrastructure and security as software, literally a binary file. Yeah?
Yep, absolutely.
Yeah.
So now next up, now that we have this all compiled in our file, we take this and we're going to run a command. This comes our one click.
Yes.
So what we're doing here is this kind of makes you almost seem like you need a sticker on your laptop in order to understand this file here. But you have this, you're basically just patching your infrastructure with that JSON file. So let's click enter. So that's it. Basically, it's been pushing that file with all of your intent in it to the NSX manager.
Yeah.
And the NSX manager is translating your intent to the desired state within the network.
So if that's built into my CI/CD pipeline, it's not one click. It's 0 clicks, right?
Absolutely.
Yeah.
We've got no more one click.
Okay, we're going one step further.
All right, so let's move on and see what we actually did. So behind the scenes, this is actually a view of the federation you're talking about. We have this global manager that's taking place. And down below, we have all of our data centers in Paris, London, and AWS. So that one click actually sent that command over to our global manager, which will then in turn send that desired state into, or the intent config into each of the local locations. And then there, it'll translate it into the desired state within the network. So let's hop into the user interface and see what this looks like. So first of all, you'll notice our new dark mode.
Yes.
So I like Mac and I like to be in a dark mode, and this is kind of a preview of.
On my phone too. Yeah,
absolutely.
Cool.
Yeah, this is the phone now too.
Yes.
This is a preview into our federation capability.
Nice.
So here, all within that same interface, right? If you noticed before, we had our branch local managers all in place.
Yeah.
We didn't have to change those. We just added that global manager to federate them.
Oh, so if I'm an existing NSX customer and I have a bunch of policies in my NSX manager, I can add federation, it'll suck those policies up into the global manager.
Yeah, exactly.
Right?
Pretty seamless.
Yeah, nothing to redo. Yeah.
So here we're seeing our global manager clusters, and if we scroll down, we can actually see our data centers, Paris, London, and our data center in AWS.
So single console, global view.
Yep. Absolutely. So let's scroll back up and take a look at our inventory. So if we look at our inventory, we have really 3 simple groupings for our application: our web tier, app tier, and our database tier, all with a span of global. And again, the span could be also site local too, but in this case, we wanted our application to be global. So let's click a look at some of our membership criteria. Here we're seeing all the VMs in our Paris data center, our London data center, and up in AWS as well. And in order to do this, if we close out, actually go to the group definition now, we can see that all we did was apply a tag that says web and production. And if we see that anywhere globally, we'll put it into that security group.
Interesting.
So from here, let's close out and go back to our security tab to see actually these firewall rules in place.
Yeah.
So in our security tab, this is our distributed firewall that we're talking about. We have our rule sets for this application. It's all pretty simple. Internet to web, HTTPS. Web to app, we have our HTTP traffic. And our app to database and MySQL. All again, that layer 7 rule engine.
It's always interesting to me that the policies that we talk about are usually as simple as that, but it could translate into hundreds or maybe even 1,000 firewall rules using 5 tuples. But here we abstract it down to web, app, database. Simple as that, right?
Yeah, exactly. Yeah. As Ambika was saying earlier, they live and die with the VM, and they move with the VM.
That's right.
So if you take that 1,000 rule set that you have, and that person that wrote that rule left the company, good luck trying to remove it.
Right. Yeah.
So now that we have our rules in place, our application's all secure and ready to go.
Nice.
So we can publish those rule sets and move on to the next scenario. So our application's up and running. And that's great. We got our application, but we need more applications, right? I mean, the business is scaling, so new applications are starting to come up in our Paris data center. So let's move forward as we move to more applications in our Paris data center. One pops up with a compliance issue, right? This is a compliance zone. It's a really high-risk application. So if anyone knows about compliance, you generally need IDS and IPS for that compliance zone.
PCI, et cetera. Right.
Absolutely.
Yes.
So normally what you would do is you'd kind of roll the truck and rack a new IDS, IPS and system, and you would hairpin that traffic through that, coming into the system at best, and probably not every single where inside that zone.
Yeah, I've talked to customers that have built a separate infrastructure for their PCI zone that is separate from everything else, and so you have two of everything. Whereas here, we can just define it in software and leverage a common set of infrastructure.
Yeah. Absolutely. So let's take a look at what the preview of IDS. So here in that same security tab, so again, this is all in that same user interface.
Nice.
We have our dashboard for IDS where we can quickly see an overview of all the events that are taking place. But let's see how this is set up in our IDS, intrusion detection tab. So here, you don't see much.
No.
That's the beauty of it, the beauty of the simplicity.
Simple.
Right? It's basically two roles.
Yeah.
One saying anything to my compliance zone or anything compliance to compliance, I'm going to add a custom IDS profile.
Yeah.
And again, this is the only rules that you need for the particular application itself. So let's click over to the profile. Or actually, we can go into compliance first. So if we look at the actual membership criteria, it's very similar to what we did with the federation example. If we click on the membership criteria, we can see that the tag is equal to compliance. It's pretty simple.
Yeah.
All automatic and all global scope. So let's apply this, and let's hop over to our profiles next. So this is where I can assign a custom profile to those given rule sets as well. So if I only want to enable a certain amount of IDS to eliminate even more of the noise, some of this, I just want critical severity for one area, or if I want all severities for another area, I can do that quickly and per application.
I mean, that's one of the things I think is interesting about IDS and IPS is that many customers will view it as a checkbox, like, oh, I have to put it in place because of compliance, but it's not really doing much. But if we have this more targeted approach of the IDS IPS where we can apply only the rules that are necessary to the applications that require them, we think we can create a much higher fidelity system and make it actually useful, right? Stopping bad guys. Stopping that WannaCry example that I talked about.
Absolutely.
Yeah. And it's as simple to do as this.
Yeah, so next up, so I mean, we protected our new applications. We're scaling out new applications every day, moving them throughout the globe. But what about all of our existing applications? So let's move on to actually before this, let's actually see what we're detecting in the events.
This is real time.
Real time. Yeah. So we actually see some real time attacks that are taking place.
Yeah.
So we can hover over one of those dots of the real time attack, click in on it, and we can drill in and start troubleshooting.
Yeah.
These are all the events that are happening across your infrastructure.
And all these events are exportable, so I can tie them into my SIM or whatever infrastructure I'm using in the security
absolutely, to do correlation.
Yep.
Definitely. So from here, we can even drill in even further. If I don't know what this CVE is, I can click in and actually view about information about the actual vulnerability as well that is taking place. All right, so now we got our application secure, and we've viewed all the events now. So now let's actually go look at some of the other parts of our data center.
Okay.
So we scaled out our application, and what about what's already there? Right, that's the hard part, right? It's like all of the stuff that's currently running in your infrastructure.
What you showed us was how I build a policy for new application, but I've got 5,000 existing applications, and you pointed out the guys that set that stuff up aren't even around anymore. What do I do?
Absolutely. Right? This is where NSX intelligence comes into play. Yeah. So all, again, in this one interface, let's hop over to our plan and troubleshooting tab. So this looks exactly like what you were showing in your slide, is this view of all the traffic. I mean, this may look a little bit scary at first, but the beauty of it is that this is always on everywhere. So we're seeing everything all at once. So in here, we can actually quickly drill into an application. Let's look at Tom's Tire Store. We just had Pirelli up here, and we want to start selling some of the Pirelli tires. The video was really awesome. So,
Ride Pirelli, yes.
So let's apply it to just our Tom's Tire Store application. So from here, we can quickly zoom in on just the scope of that application itself. And here, we're actually running some things in the public cloud, some things in containers, and also into bare metal. And if we hover over one of the links, we can quickly view really that depth of detail about all of the traffic that's going across this link. Not just the IDS that we just talked about, but also the unprotected or the protected flows. And it's really great for audits.
Yeah. I just think the visibility alone is really interesting because your infrastructure is this big, opaque blob. And now all of a sudden we can show you, here's the Commerce app, and here are the pieces of the Commerce app, and here's how these things connect and update, and the security and network policy all in a single integrated view that can span private cloud, public cloud, all of your infrastructure from a single view.
Absolutely. So that's why. So next we zoomed into one of those areas. So those are the overall groups. But if we want to zoom into an actual VM, so we're clicking on the flow details for that VM, we can see a tremendous amount of detail. Normally, if you look at flow data and you're thinking network, you see IP addresses and ports, but not here, right? We see process, what user spawned that process, and was sending to what destination process. So for example, MongoDB sent some traffic with the REST protocol, which is Redis, onto the other side.
Yeah.
So you see all the details, full
Yeah.
details.
That's what we were talking about, intrinsic security. So we have that intrinsic understanding of the application, and we map that to the flows and the packets and the infrastructure. So you get a view that actually makes sense and is relevant. It's really powerful.
Yeah, absolutely. So let's close out of this, and we can actually see even more detail from that.
Yeah.
So we can click on the VM and click on VM information. Here we see all the information from vCenter. And then we can also, we just talked about intrusion detection, we can see what intrusion detection events that are taking place on that same flow as well.
Nice. Yep.
So let's exit out of here, but you may be thinking, great, that's a lot of great visibility. I can see a lot of information, but I want to create a policy.
Yeah.
It seems like, information overload.
Right.
So that's why we created this nice little magic wand icon to run role recommendations for you. So let's go ahead and click and let's start a recommendation. So here you can see that since we're on all the time, we can actually select a range, going back up to 30 days. So this application was doing some new stuff today, so I'm just going to run it for today. So let's start a discovery. So our discovery will take a little bit of time to finish, and it'll pop up with a recommendation. So we're finished, we have 4 groups, number of services, let's view our recommendation. So here is our recommendation.
Interesting.
And it's a grouping of all your services, right? So your public cloud to container groups, or your cart totals, and all of the services and profiles that are applicable to that.
So if I'm an existing NSX user and I've got existing infrastructure, this is a software upgrade that will allow me to analyze and understand what's happening in this infrastructure and then automatically generate these rules.
Yep.
No human intervention.
Yeah,
the computers did that.
Yeah, absolutely. Yeah. So let's see how we would go apply this. So we would proceed. We can move it around the rule table if we want to, but this is where it gets kind of scary.
Right.
Right. If you've ever applied any type of firewall policy, you're just sitting there waiting for the phone to ring.
Yeah.
Right. You screwed something up, and you're like going, I just created all this with some auto magical machine learning thing. Am I really going to trust this?
My brother-in-law was a firewall administrator at Xerox, and he used to tell me, like, every time I would update that rule table, I'm just convinced that I'm going to block something for the CEO, and it feels like I'm working in hex. You know, it's this really primitive 5-tuple rules just grow and grow and grow. So it's scary to make a change. This tool allows you to manage that fear, right?
Yeah, so we have this little box up here saying simulation.
Yeah.
So now, since we're always on, we already are looking at all the information across time, we can run a simulation of what those rule changes would have been across all the traffic that have been running across your network.
Yeah.
So you can be really sure before you push that publish that nothing's going to break.
Yeah, that's awesome, right? So we've been talking about how do we operationalize this stuff? How do we make it simple to run this stuff at scale? This is a perfect example where we can automatically identify the flows, automatically generate the rules, and then give you a tool to simulate it to make sure that you've got it right before you deploy. That's really powerful.
Yep. Yeah. So let's go ahead and push publish. Publish our changes, and our application is now completely secure. We don't have any more unprotected flows.
Yeah, everything's green on the chart. You know, red is bad, green is good.
Exactly.
Yeah, good.
Great. So let's move on. So we've looked across data centers, public clouds. What about the users? Right. We talked about SD-WAN.
Right.
So how would we go troubleshoot an issue that happens that spans everything?
Yeah.
So let's hop into vRealize Network Insight. So this is really going to showcase the breadth of what we can do with our tooling. So here is vRealize Network Insight, or what we like to call VRNI, and VeloCloud is built into that interface now. So here we're seeing a view of some of our branch locations throughout the globe, as well as a gateway in our AWS instance. So let's go ahead and actually zoom in on one of those flows. So here we're actually going to see a path drawn between all this infrastructure. Let's go ahead and click on it and start our path.
This is cool.
So this is actually a full flow end to end. So we start with our client or our user in the branch.
Yeah.
We're going to our VM in the data center.
Yeah.
And then on the other side, we're going from our data center VM out to our public cloud instance to do some other post-processing work.
So we talked about analytics and the ability to troubleshoot and understand your application. VRNI is the tool that gives you physical and virtual data center and branch. So it's breadth. Whereas the NSX intelligence was depth, right? It went down to the individual VM. It could look at individual packets. And these two things are working together to provide this kind of a view. It's really slick.
Yeah, we didn't stop at the virtual too, right? If we scroll down actually now too, we can look at all the physical infrastructure too.
Right.
I mean, we don't want to stop at just if you're doing the troubleshooting issue.
You can actually see the network fabric in there.
Yeah, exactly. Those are the physical underlay.
You know, when there's a problem with an application and a branch user is like, hey, it doesn't work, whose fault is it? Always the network. That's the first thing. Oh, the network must be broken. And so this is a tool that can allow you to quickly resolve and figure out, is it a network problem? Is it a database problem? Is it a data center problem? All of that in a single view. Yeah, very effective.
Great, and with that, we've shown a full end-to-end of what we can do from a very broad perspective, or very deep with what we can do with security.
Great. Awesome. Jacob, thank you very much for the demo. That was really informative. And so that's our mission here, is to deliver world-class security that takes advantage of the intrinsic advantages of our platform to be able to deliver very, very complete solution that's easy to operationalize. This solution has matured to the point where we can actually replace dedicated, expensive, proprietary hardware and save a bunch of money in the process. So it's easier to use, literally better, faster, and cheaper. And then when we combine the network analytics, where we can show application response time from the data center all the way out to the end user and quickly diagnose, is this a WAN problem? Is it a database problem? Is it a data center problem? Is it a switching problem? These are the types of tools that are going to dramatically increase your efficiency and bring you closer to that public cloud experience in your private cloud infrastructure. So thank you all for coming today. Now, before we leave, there's a couple of housekeeping items. If you remember last year, I loved the Willy Wonka golden ticket. So we're doing the same thing this year. There are two seats out there that if you look under your seat, look for a golden ticket. Two people will find a ticket that allows them to get the Bose noise canceling. Wave a ticket if you find it. Oh, if it hasn't been found, there it is. Okay. And Calvin will provide you with the headset. We've also got a bunch of great references here where you can go and access a bunch of this information. We have hands-on labs, so you can actually get in and you can see how to do some of the things we showed you in the demo with NSX and with our SD-WAN and with Vernie. Thank you all for coming and enjoy the rest of the show. Take care.